Hello, my name is Pier Giuseppe Morone and I'm a professor of economic policy at Ulitelma Sapienza. I am the leader of StarProBio, which is an H2020 project funded by the European Commission. This is a research and innovation action which aims at assist the transition out of a fossil-based economy into a bio-based economy. We do so with a twofold objective. On the one hand, StarProBio aims at defining a sustainability assessment tool in order to define the level of sustainability of bio-based products, and then on the other hand we aim at defining a set of policy guidance in order to speed up the transition by means of market uptake of bio-based product. In order to do so, we have to pull together several partners. We have 15 partners, including university, NGOs, small and medium companies, as well as research centers. Specifically, we have the University of York, the Technological University of Berlin, the Agricultural University of Athens, DBFZ, which is a private research center from Germany, SQ Consult, the University of Bologna, UWM, which is a university based in Poland, Chemprof, which is a small chemistry company in Poland, Quantis from Switzerland, Novamont, which is a large enterprise from Italy, the Swedish Environmental Protection Agency, the University of Santiago de Compostela, and ECOS, which is an NGO based in Brussels, and then finally Agrovet from Austria. So we have multifold methodology, multifold approach, which eventually will lead us to develop two major tools, which will be the legacy of our project. On the one hand, we have the SatProBio, which is the sustainability assessment tool, and then on the other hand, we have the SeedProBio, which is a system dynamic tool in order to make policy scenario comparison.
The production of bio-based products is a great opportunity to boost the concept of bioeconomy and avoid the use of fossil fuels. However, the production of feedstocks must be carried out in a responsible and sustainable manner. Science changes can be inferred in the use of biomass for non-edible purposes and in those affecting land use. Therefore, it is crucial to evaluate the sustainability of bio-based products, taking into account all stages of their life cycle, from raw materials extraction to end of life. This will increase consumer recognition of their environmental, economic and social benefits.
A multitude of raw materials can be used as alternative to fossil fuels to produce the target bioproducts of the project: packaging film and agricultural mulch film. They may comprise first-generation feedstocks which compete with food and feed markets, for example maize grain, wheat grain, sugar beet and sugarcane, residues from agriculture and forestry operation, that is second-generation feedstocks, that is wheat straw, maize stover, third-generation feedstock, macro and microalgae, and residues from industrial processes, namely fourth-generation feedstocks, that is sugar beet pulp, municipal solid waste, for example. The framework of this project encompasses three of these alternatives: first, second, and fourth generation, which are maize grain, maize stover, and sugar beet pulp.
The use of methodologies such as life cycle environmental, social, and economic assessments help stakeholders investigate the sustainability aspects of bioproducts and make decisions. It allows to answer questions such as how much CO2 is my bioproduct releasing compared to fossil fuels alternatives? What are the internal and external costs of my bioproduct? Is my bioproduct contributing to society?
Another important aspect of the bio-based products for their sustainability assessment is the indirect land use change. Why is that? We have to feed our livestock, we have to feed our population, and we are making room to a new category of products, which is the bio-based products. So if we take the global land use system, which is a limited one, and even if we take a small portion of that, so this fertile land, what we are doing, if we don't change our diets, if we don't change the yields, we will leave Saskia and Bill here unsatisfied. They will look for new products in the global economic systems. They will look, therefore, for new lands, and this will induce a new change after that one, which is called indirect land use change.
Therefore, we developed a model that takes into consideration the industrial and agricultural sector together with the practices that can potentially reduce ILUC, for example, the use of waste and residues, or the land use practices, agricultural practices, and the unused land that could reduce the use of land. And with this model, we were able to estimate the ILUC risk associated with the production of bioplastics by 2050, together with the different policies. By taking the model and running it multiple times, we were then able to make local sensitivity analysis in order to inform policymakers about which of those policies are the most effective. Finally, we parameterized the model in a tool that is easy to use and easy to understand, and could help potentially companies, certification bodies, and policymakers to assess their ILUC risk.
Although we are very well aware that still a lot needs to be done in order to finalize the transition out of a fossil-based economy into a bio-based economy, we are also aware that we, as a European-funded project, we as StarProBio, are doing our share to make this change happen. And this is the big and the best rewards we can possibly get.